Question 29, Part A. The diagram shows the graph of y equals 2 to the power of negative x. Also shown on the diagram are the first 5 of an infinite number of rectangular strips of width 1 unit and height y equals 2 to the power of negative x for non-negative integer values of x. For example, the second rectangle shown has width 1 and height half. The sum of the areas of the rectangles forms a geometric series. Show that the limiting sum of this series is 2. The heights of successive rectangles forms a geometric series. Now the height of the first rectangle is 2 to the power of 0, which is 1. The height of the second rectangle is 2 to the power of negative 1, which is 1 over 2. The height of the third rectangle is 2 to the power of negative 2, which is 1 over 4. The height of the fourth rectangle is 2 to the power of negative 3, which is 1 over 8, and so on. So the geometric series is 1 plus 1 over 2 plus 1 over 4 plus 1 over 8, and so on. We want the limiting sum of this geometric series, and it will be a limiting sum because the common ratio r is half. And the first term of this geometric series is 1. So the limiting sum is given by the formula a over 1 minus r, which equals 1 divided by 1 minus 1 over 2, which equals 2 as required. Part B. Show that the definite integral from x equals 0 to x equals 4 of 2 to the power of negative x dx equals 15 over 16 ln 2. Recall that the first derivative with respect to x of 2 to the power of negative x is equal to ln 2 times 2 to the power of negative x. Dividing both sides of this equation by ln 2, we get 1 over ln 2 times the derivative with respect to x of 2 to the power of negative x is equal to 2 to the power of negative x. Hence, the integral of 2 to the power of negative x from x equals 0 to x equals 4 is equal to 1 over ln 2 times 2 to the power of negative x from x equals 0 to x equals 4. Applying the limits of integration, that equals 1 over ln 2 times 2 to the power of negative 4 minus 2 to the power of 0, which equals 1 over ln 2 times 1 over 16 minus 1, which equals 1 over ln 2 times 15 over 16, which equals to 15 over 16 ln 2 as required. Part C. Use parts A and B to show that e to the power of 15 is less than 2 to the power of 32. The rectangles overestimate the area under the curve, hence 15 over 16 ln 2 is less than 2. Now 15 over 16 ln 2 represents the exact area under the curve from x equals 0 to x equals 4, and this is from part B, and 2 represents the limiting sum of the area of the rectangles from part A. Multiplying both sides of the inequality by the denominator 16 ln 2, we get 15 is less than 32 ln 2, and the 32 can be brought back inside the logarithm by expressing it as an index. So 15 is less than ln of 2 to the power of 32, and we can cancel the ln by raising both sides of the inequality to base e. So e to the power of 15 is less than 2 to the power of 32 as required.